Yeah. So these are few questions we have covered in instantaneous motion or variable accelerated motion, both in terms of differentiation and integration parts as well. Next topic is projectiles. So the key points in the projectile equation or projectile motion you need to remember is, in a general projectile motion, you need to know the maximum height equation, time of flight and range. So over here, the maximum height equation will be u square sine square theta by 2g. Time of flight equation will be 2u sine theta by g, and range equation will be u square sine 2 theta by g. This range can be maximum at 45 degree. Therefore, its value will become u square by g. The relation between maximum range, range and maximum height is r is equal to 4h cot theta. And other than this, these few things can help you to understand the equations or questions very easily. If you still need one more equation to solve the projectile motion based things, you can just know the trajectory equation. It's quite okay if you don't know this, you can still solve the equations. Just for safety, it is better to know this equation. X tan theta minus g by 2 into u square by x square cos square theta. So these are few basic equations that you need to know. If it is for the first time you are beginning this particular thing for any reason, you can still, by knowing these equations, you can still have the answers for the projectile motions. On the other, at the maximum height, velocity will be only in x direction, that will be u cos theta, and vertical component of the velocity will become 0. Other than that, we can take horizontal projectile motion based questions, which will also follow from the almost the similar thing, but horizontal projectile motion will begin from a particular height and object will be projected horizontally. In this case, time of flight equation will be root 2h by g, and range equation will be u root 2h by g. So these two equations can help you to solve any questions based on horizontal projectile motion. Let's go for some questions based on projectile motion. Number 1. Particle of mass m is projected with velocity v, making an angle of 45 degree with the horizontal. When the particle lands on the level ground, magnitude of change in its momentum is. Let's understand clearly. The particle has gone through this projectile. So, if you see the initial velocity, it will spread into two components. One is ux and another is uy. When it reaches the bottommost point, there also it will split into two components. One is vx, another is vy. Since there is no acceleration along the horizontal direction, the horizontal component of velocities will not change. Therefore, momentum along the horizontal component will also be 0. Before that, what is momentum? Mass times velocity. And momentum is also vector quantity. So here, total momentum change along horizontal direction is 0 absolutely. So if you just need to verify only vertical direction momentum change, that will be more than enough. So delta p, that is momentum change along y direction, what will be? And vector quantities, if you verify, this is uy, so momentum is m into final velocity and minus initial velocity. So I can write over here minus m vy. Vy is, we will write what vy is. So minus m vy minus m uy. Now, if you know some small techniques in horizontal, in this level ground projections, in a level ground projections, what happens is the vertical component of velocity of initial velocity will always match the same with the vertical component of the final velocity. In other words, from the same level, if you are projecting an object upwards vertically with 10 meter per second, it will go up and it will come back such that when it reaches the level ground, the same level, it will also come back with 10 meter per second velocity, but it will be downwards. I repeat it, When you project something up with 10 meter per second velocity, when it goes up and comes back to the same point, it will move down with the same velocity 10 meter per second but in the downward direction. So Vy and Uy can be same. So here we can understand that Uy value is U sin theta, or sin theta is sin 45, that sin 45 is 1 by root 2. So Uy is U by root 2. So if you observe this entire quantity, you can directly write it as 2 times magnitude of change in momentum. If you write 2 times mu by root 2, or we can write root 2 mu, which is option C. Okay, I repeat the gist over here again. Momentum, if you want to find the change in momentum, in the projectile motion, the horizontal components of velocities will not change because acceleration is not there. Vertical components of velocity only will change because acceleration is there only in the vertical direction. And on a level ground, velocity values will be same but opposite in directions. Considering that, we got the momentum change as root 2 mv. Missile is fired for a maximum range with an initial velocity 20 meter per second. If g value is 10 meter per second square, range of the missile is. They have already said it is fired for a maximum range. Maximum range equation I gave you, R max is equal to U square by G. Okay, so therefore U value is given as 20 meter per second, that will be 400 divided by G is 10, so that should be 40 meters, option D. Okay. Next question. Particle is moving in a circular track of radius r with uniform speed, takes time t to complete one full revolution. If this particle were projected with the same speed at an angle theta to the horizontal, the maximum height attained by it equals 4r. Then the angle of projection theta is given as. So in this there are two things. One is circular motion. So one thing they said, it is moving with uniform speed, which means in a uniform circular motion of radius r, it completes the one full revolution in time t. First, let's just analyze what is the speed of the particle if it is moving in time t in a circular track of radius r. Particle is moving with speed v. So we can analyze this equation directly using v is equal to r omega. Or we can write v is equal to r 2 pi by t, since omega being the angular velocity is equal to 2 pi by time period. This is the equation for velocity. Let's go back to the question once. In the question they are saying, if this particle was projected with the same speed, which speed? The speed which we have calculated now, at an angle theta to the horizontal, maximum height attained by it equals 4r. The angle of projection theta is given by. So if this is the initial projection velocity in the projectile motion, that means the object is now fired with this velocity at an angle theta. Therefore, it will attain some maximum height. And this maximum height equation they are saying it as 4r. How much shall be the angle value? So how will we get this equation? We just need to substitute in the maximum height. I just told you what is the maximum height value. They gave it as 4r. That means this shall be equal to the maximum height equation as v square sin square theta by 2g. Now v value is this much. Just substitute over here. 4r equals to 4r square pi square by t square multiplied by sin square theta by 2g. Cancel all the relevant terms, 4 and 4, r and r for once. We need the angle, so separately write sin square theta apart and take everything to the other side. If you take everything to the other side, that will become 2g t square by r pi square. You take the square root to the other side, that will become, or square to the other side, that will become square root. You take sine inverse, so theta will be equal to sine inverse of square root 2g t square by r pi square. So sine inverse root 2g t square by r pi square. Let's see which option is matching. Sine inverse, so there is two sine inverse equations. Here we got the answer 2g t by pi square r to the power 1 by 2. So that will be our answer. Okay. Next question. Ball is projected with velocity 10 meter per second at an angle of 60 degree with the vertical direction. Its speed at the highest point of its trajectory will be. Already I told you, at the highest point of trajectory, the speed will be only u cos theta, because vertical component of velocity will be 0 and horizontally velocity will not change. Now, the projectile is projected with a velocity 10 meter per second at an angle 60 degree with the vertical. That means with the horizontal the angle is 30 degree. So here 10 cos 30 shall be the value of velocity at the highest point also. So cos 30, that will be root 3 by 2, 10 into root 3 by 2 will be 5 root 3 meter per second, which is option A. Velocity of the projectile at the initial point A is 2i cap plus 3j cap and its velocity at the point B. This question we have already discussed in terms of momentum. So the same quantity or the same discussion we can have it over here as well. So if this is the initial velocity, it can split into two components, ux and uy. And this is the final velocity v. It can also be split into two components, vx and vy. I told you already, along x-axis acceleration will not exist. So if acceleration is not there along x-axis, velocity does not change. So therefore final velocity should have the same. So what is initial velocity is given as 2i cap plus 3j cap. So initial velocity, final velocity, in that the x component will stay as it is. That means this will also be 2i cap. So you can eliminate the options A and B. Next, we need to check for y component. I told you y components in the same ground level, okay, the y components of velocities will be equal in magnitude but opposite in direction. So if this is upwards, which is given as 3j cap, then the other side it should be downwards with the same quantity 3j cap. That means minus 3j cap. So the answer is option C. By knowing this small logic, you don't have to work out the equation through the equations of kinematics. Directly you can opt the answer. Next question. Projectile is fired from the surface of the earth with a velocity of 5 meter per second at an angle theta with the horizontal. Another projectile fired from another planet with some other velocity 3 meter per second, but angle is same, follows a trajectory which is identical with the trajectory of the projectile fired from the earth. Value of acceleration due to gravity of the planet is. So let's understand the question very clearly. There is earth and there is some other planet. From earth somebody fired the projectile with velocity 5 meter per second and it followed a particular trajectory and ended up over here, and the angle of projection is theta. Now we went to some other planet upon which we again fired the projectile with a different velocity, this time 3 meter per second, but they said the trajectory of this projectile in the other planet traces the same thing. This equation, this particular statement is really important in solving this question. If trajectory is same, what does that mean? The range is same. Okay, the horizontal range is same. All you got to do is equate the range values of both the planet and both the other planet and of the earth. So if you equate the range, what is the range equations? And here also the angle is same. So range equation is u square sine 2 theta by g. And what is difference? What is same here? Angles are same. So you can eliminate the sine 2 theta part. So you can just write u1 square sine 2 theta by g1 is equal to u2 square sine 2 theta by g2. So this is for the earth, this is for the planet. Same angles, so sine 2 theta you can cancel. U square values, one is 5, that is 25 by g1, and that should be 9 by g2. So g2 is equal to 9 times g1 divided by 25. So this value will be approximately 3.5 meter per second square. So which is option A. Okay, it is simple. So the technique is this particular statement. Trajectory equal means the horizontal range will also be equal. So the next topic, position, velocity and acceleration vectors. This is in a two-dimensional plane. So in a two-dimensional plane, how do we write the velocity vector, position vector and acceleration vector? See, in a graph, or if you, with respect to any frame of reference, if a particle is over here, in your 10th standard, you would have marked this as coordinates x comma y. On an xy axis or on an xy plane, you could have marked this as x comma y. According to vectors, the same thing we will write it in terms of a vector quantity as position vector. So here we will write this position vector as a combination of x and a combination of y. So therefore, position vector r, we can write it as x I cap plus y j cap. As I said, in your 10th standard you wrote it as coordinates x comma y. Here it will be x I cap plus y j cap. You want to find velocity vector, differentiate the position vector with respect to time. We have learned this already. You differentiate the position, you will get the velocity. So if you differentiate this, any position you are differentiating in x direction, you will get Vx and then Vy j cap. I can write it over here where Vy is differentiation of y position and Vx is differentiation of x position. And finally, if you want acceleration vector, you can write it as differentiation of velocity vector, that should be equal to ax I cap plus ay j cap. How do you get ax and ay? We can write ax is dvx by dt and ay is dvy by dt. So basically what I am trying to say is, these equations we saw it already. Position differentiation, velocity differentiation in the instantaneous motion. Same equations we are applying here, but the only difference is we are applying here separately for each individual directions. One time for x and one time for y in both cases. Okay, so let's see some questions based on this. Next, position, velocity and acceleration vector based concept. Now in this topic you need to know how to write velocity vectors, acceleration vectors and position vectors. If you know that, we can solve these questions quite easy. Let's see the question. Particle is moving such that its position coordinates are 2, 3 at time t is equal to 0 and 6, 7 at time t is equal to 2 seconds and 13, 14 at 5 seconds. Average velocity vector is between what time frames? 0 to 5 seconds. So if we need to understand this question, first we need to know how to write the velocity vector. And average velocity vector, it is final position minus initial position. So final position as a vector minus initial position as a vector divided by change in time. So let's write the final position vectors over here. So final position vector is at 5 seconds, it is at 13, 14. So that will be 13 I cap plus 14 j cap. Initial position vector is 2, 3. That is 2 I cap plus 3 j cap. We just need to subtract these both. So if you subtract these both and substitute in the numerator of the first equation, you will get velocity vector as, so here this will be 13 minus 2, that will be 11 I cap plus 11 j cap divided by 5 seconds. So your velocity vector should be 11 by 5 into I cap plus j cap, option D. So the next question in this topic is, particle has a an initial velocity of 3 I cap plus 4 j cap and has an acceleration of so and so, and its speed after 10 seconds is. This is again based on instantaneous motion, not exactly, based on kinematic equations. So you can relate. So why are we considering this question under position, velocity and acceleration vectors is, since the quantities are given in vector quantities, but still you can solve this question using the kinematic equations. So we know that acceleration as a vector is equal to v minus u by t. So we want this velocity, speed, that is magnitude of this velocity after 10 seconds. So that means V is equal to U plus AT. U value is this much, 3I cap plus 4J cap plus A into T. So T, 10 seconds magnitude, you multiply with the acceleration, that will become 4I cap plus 3J cap. So over here you can get a total of 7I cap plus 7J cap. That is velocity and its magnitude, which will be the speed, 7 square plus 7 square, or we can just write it as 7 root 2, and the answer is B. Okay. So we'll see the question, another question in this same topic. The x and y coordinates of a particle at any time are given as the following. So x position is given 5t minus 2t square, and then y position is also given, that is y is equal to 10t, where x and y are in meters and t is in seconds. The acceleration of the particle at t is equal to 2 seconds is. So I told you already how to write the acceleration vector. First, if you want to write acceleration vector, it should be a combination of ax I cap plus ay j cap. Now to get ax, you need to differentiate vx. To get vx, you need to differentiate x. So first let's just differentiate the x components to get velocity along the x direction. Along x direction, if you differentiate the x component dx by dt, you will get the value as 5 minus 4t. If you differentiate vy, that will be just 10. Then you differentiate this vx again. So I'm doing it over here. You differentiate the vx to get ax. Ax value will be obtained by dvx by dt by differentiating vx component. So that will give us 5 differentiation is 0, and this will be minus 4. And ay value, already vy is a constant, that is 10, so ay will be 0. So therefore, as a total answer, acceleration vector can be ax I cap, that is minus 4 I cap, and ay j cap, but ay value is 0. So you can see by magnitude wise, the acceleration value will be just 4 meter per second square. But since it is a retarding value, they have not mentioned whether it is a retardation or acceleration. So simply we will take along with the sign convention as well. So the answer is minus 4 meter per second square. So these are all few questions that were asked in the previous years regarding the chapter of kinematics. In the next video, we will cover some more questions in relative motion and circular motion as well. Circular motion, you can also do it under rotational mechanics or system of particles chapter. Under the context of relative motion, we will have another video to discuss the previous year questions. Thank you.